Alright, we're going to look at, excuse me, we're going to look at rules of exponents in this video. And we know from earlier on in the semester that the number on the ground, number or term or expression on the ground is the base, and the little number up in the air is the exponent. So if we were asked to evaluate something like 2 to the third power, that means to take 2 times 2 times 2. And we know 2 times 2 times 2 is not 6, but that, in fact, is equal to 8. Now, if we were given x to the third power, we know that's x times x times x. But again, we like exponential notation because this is much nicer to write on our page than that is right there. Now, when we're doing some of these rules so we can see them a little more clearly, I am going to expand some of the expressions. But in our homework or our quizzes or our tests, we're going to want to write them as concisely as we can. 2/3 to the third power, we're going to write as 8 always, but x cubed, we don't need to write it as xxx. So maybe I'm asked to multiply x cubed times x squared. Okay. Again, just for this example, there's my x to the third, and if I'm supposed to multiply it by x squared, if we start counting up all of the x's, it looks like I have x times itself 5 times. When our bases are the same, and we're multiplying two terms or expressions together that have the same base, then notice what we did there with the 2 and the 3 to get the 5. We added them together. Meaning if we have x to the 4th times x to the 9th, we can add 4 plus 9 and get x to the 13th. If we have y to the 5th times y to the 8th, we can add the 5 and 8 together and also get y to the 13th. If we have x to the 3rd times y to the 4th, then those bases aren't the same. So this is the best we can do. Also, if we have 2 to the 3rd times 2 to the 4th, rules of exponents are one of very few situations where if I give students numerical bases instead of x's and y's, they're more likely to make a mistake. Notice on all the examples we've done so far, the x was the base and it stayed x. Here y was the base and it stayed y. In the rule we said a was the base and it stays a. So the 2 is going to stay a 2. And 3 plus 4 is equal to 7. And so we have 2 to the 7th power. Now if we multiply on our fingers or on our calculator or whatever, 2 times itself 7 times, we get 128. When our bases are the same, and we're multiplying them together, then we add the exponents together. We can extend that idea using our commutative properties. Commutative property. If I'm asked to multiply 2x squared y cubed times 3x cubed y to the 5th, and we just, we can regroup and multiply the pieces that are the same together. 2 times 3 is 6. X squared times x cubed. Since those have the same base, we can add the exponents together and get x to the 5th. And we can do the same thing with the y's. 3 plus 5 is 8. Okay. So the product there is 6, x to the 5th, y to the 8th. Maybe we have 5x to the 4th, y to the 9th, times negative 2x cubed y. Okay. Okay, go ahead and pause the video, find that product using the correct rule, and then turn the video back on to see if you're right when you're done. 5 times negative 2 is negative 10. 4 plus 3 is 7. And 9 plus 1 is 10. Don't forget that if there's no exponent written, then it's understood to be a 1. So we have to remember to add that 1 into the 9 that's already there. So here is our first rule of exponents. I'm going to keep these individual so I can put the right ones in the right classes as I go along.